Trust me. Okay. Today we are out at 1:39, so we don't have a lot of time, but we are going to get started because this does take a little bit longer, so we need every extra minute that we can get. We're going to talk about conic sections, and conic sections have to do with cones. And if you were to slice a cone right at the top, what kind of shape would you get? A circle. A circle is a conic section because if you were to section a cone, you could come up with a circle. Suppose I cut it like that, what shape would I get? Like a weird oval thing. Yep, we call it an ellipse. And if you cut it parallel to the side, you come up with a parabola. There are all sorts of different shapes that you could come up with when you cut a cone. These are called conic sections. Now, why they relate to trigonometry? Oh well. So, what is a parabola? We're going to define it on Monday. But the equation we're going to use for a vertical parabola is y is equal to a times x minus h quantity squared plus k. Does that look familiar? Thank you, Noah. Noah says it looks very familiar, and it should. Why? Because you've done it like three times already. It's not like a circle thing. It's like a parabola. But I understand. Yep. Very good. X minus h quantity squared, y minus k quantity squared is r squared. That's the circle. Good job. Yep, very proud of you. So, as I graph this, okay, draw my graph. Oh boy. So that point right there is going to be HK. That is your vertex. The direction of opening, if A is positive, it goes up. If A is negative, it goes down. There are important points to a parabola that we have not talked about before, but one of them we have, the axis of symmetry. The axis of symmetry is a vertical line in this case. It divides the parabola in half, and it goes through the vertex. A vertical line has the equation of x equals or y equals. X equals. And it goes through the x value of the vertex, which is h. It then has a focus point and a directrix. A focus sits on the inside of the parabola. All right, F for focus. Directrix sits on the outside of the parabola, and it's not a point, it's a horizontal line. No, but I like you making connections. So P units from the vertex for the focus and the directrix. So there should be a question going off in your brain right now. Yep, they're both P units away from the vertex. But you should be asking something right now. How do you find P? Very good. A is equal to 1 over 4P. A is 1 over 4P. Are you okay with that? Great. So A is 1 over 4P. So how do we locate the focus? We go P units from the vertex. If I move up, does that change the H value or the K value? So it's H, comma, K plus P. And then the directrix is P units lower. That's a horizontal line. Is a horizontal line an equation of x equals or y equals? Y equals. And that changes the y value of the vertex. So the y value is k, and what we are going to do is we're going to subtract p. finally, we have the length of the lattice rectum. This is a word that many people find awkward to say. Very good, Samantha. Thank you for sharing. You put in such great perspective. So we're going to practice just to get the awkwardness out of. Okay, all right. So the green segment represents the lattice rectum, and the length of it is the absolute value of 4p. So once you find p, multiply it by 4 and take the absolute value, and that's the length of the lattice rectum. So you do not use sine or cosine or tangent at all, okay? I know to some people that brings you comfort. To some of us, we say, well, hey, I loved sine and cosine tangent because everything was connected together when we did it, but now we're stepping away. So hopefully this will go well for you, okay? So flip it over. We're going to do one problem together. I will show you on Monday why this falls into the scope of trigonometry. But today we just want to, with this, yeah, by the way, YouTube, it's a late start today, so our days have gotten all messed up, so kind of flying by the seat of our pants. So we're going to do direction, vertex, axis of symmetry. We're going to do focus, directrix, and the length of the lattice rectum. By the way, you get to use notes for this test, and you have two options. You can either use the notes that I provided for you on the very last page, which I would discourage you from doing, because I think that they're too complicated to really look at and follow. Instead, I would encourage you to look at the notes that we wrote down, like this, and rewrite them in your own way, or simply cut them out and paste them onto a sheet of paper. But you do get your own notes for this test. Everybody clear? You do not get examples, though, of how to do the problems. No, we're not going to do that. Direction, up, down? Which one? Up. Somebody determine for me the vertex. HK, so it's going to be what? -2, +3. Making a 6x6 graph. I'm going to plot -2, 3. It's free country. You guys do whatever you want. What I think is best to do is to plot the points and then make all the labels. Okay? So some people try to fill out the axis symmetry, the focus, the directrix, all that, and then put it on the graph. I think that's the wrong approach. I say graph it as you go. Because if this is the vertex, can I now draw the axis of symmetry? Yes, you can. The axis of symmetry is a vertical line that goes right through the vertex. And once I've drawn it, it's then easy for me to name it. What is the name of that line that I just drew? Very good. In order to find the focus, the directrix, and the length of the lattice rectum, I must first find the p value. What is the equation for p? A is 1 over 4p. Well, what is your a value in this problem? 1/8 is equal to 1 over 4p. Cross multiply, and what do you get? 8 is 4p, and as Parse said, then p is equal to 2. So what do I do with that 2? Well, I move 2 units from the vertex. From the vertex, I move 2 units on the inside, and that's my focus. I plotted it. Let's name it now. What's that location? -2, 5. I would then like to plot another point to draw the directrix through. I move 2 units to the outside, and I draw that imaginary line for the directrix. Name that line. y is equal to what? 1. Finally, the length of the lattice rectum, the absolute value of 4p. 8. So what that means is I move 4 units on each side of the focus for a total of 8. And that tells me how wide I should be making my parabola. So as I start at the vertex and I draw it through the focus or through the ends of the lattice rectum, that tells me how wide to make my parabola. What do you think? Not too bad? Good. It's going to be a busy week next week with our homework that we have. We're going to have to really stay on top of things. Okay? But we'll pick up with this on Monday.